All right, welcome to the Explainer. Today, we're going to break down the two main types of networks that basically run our entire digital world, LANs and WANs. You're using them every single day, probably without even thinking about it, so let's get into what they really are. So let's start with a question that's probably happening in your house right now. Ever stop and wonder how your laptop, your phone, your printer, and maybe even your smart speaker all just talk to each other so effortlessly? Well, the answer is they've formed their own private little digital community. It doesn't matter if they're plugged in with old school Ethernet cables or chatting wirelessly over Wi-Fi, they're all part of the same local team. And this private little club brings us to our very first key concept, the local area network, or what everybody just calls a LAN. So what is a LAN? At its core, it's a network that's limited to a pretty small space. We're talking about a single room, maybe your whole house, an office building, or even a college campus. The key thing here is that you or your company own and control the whole thing. It's your private network. So what makes a LAN a LAN? Well, because you're only covering your own small private area, it's a lot cheaper to set up and run. But the biggest advantage, the real kicker, is speed. Inside your own local network, you can get some seriously fast connections. And here are the actual pieces that make it work. You've got your usual suspects, computers, servers, maybe some phones, all wired into a central hub called a switch. And those connections themselves, usually your trusty Ethernet cables, are what we call LAN media. Now, LANs are fantastic for keeping things connected locally, but they have one really big limitation. So here's the deal. The greatest strength of a LAN, the fact that it's local, is also its biggest weakness. It's designed to connect things that are close by, which means it can't, on its own, connect you to anything that's far away. And you can see how that poses a huge problem for a modern world, right? I mean, how do you connect your office in New York with your other office in Tokyo? How do you check a website that's hosted on a server on a completely different continent? The solution to that giant problem is a totally different kind of network, one that's built specifically for long distance. And that's where the Wide Area Network, or WAN, comes into play. A WAN is what connects all the different LANs together, across cities, across countries, and yeah, even across continents. And the most famous, most massive WAN on the planet? You guessed it, it's the internet. Now, a WAN is a whole different beast. Unlike your private LAN, it's a massive, shared, public space. No single person or company owns the whole thing. And because of that huge shared infrastructure, it's more expensive to use, and as a general rule, it's a whole lot slower than your local connection. So how do you get out of your private LAN and onto the giant WAN? Well, that's the job of your router. Think of it as the gateway. It takes all the traffic from your local network and sends it out over the WAN media. And that's just a fancy term for the whole global web of fiber optic cables and satellite links that make up the cloud, which, let's be honest, is really just the internet. So now that we've met both of our players, the local hero and the global connector, let's put them head to head and make the differences crystal clear. This table just lays it all out perfectly. You've got scope, small area for a LAN, huge area for a WAN. Ownership, private for a LAN, public for a WAN. Cost, LANs are cheaper, WANs are more expensive. But look at that last row, speed. That's the big one. A LAN can go from 10 megabits per second all the way up to a blazing fast 10 gigabits. A WAN is, well, it's much slower, usually somewhere between 64 kilobits and maybe 8 megabits per second. And if that table didn't make it clear, this chart will. To really put that speed difference into perspective, a high-end 10 gigabit per second LAN connection is more than 1,200 times faster than a typical 8 megabit WAN connection. That's not a small difference. That is absolutely massive. So the takeaway here isn't about which one is better. Honestly, that's the wrong question to ask. The real magic is understanding how these two networks have to work together to create the connected world we all live in. I love this analogy because it just clicks. Think of every LAN in the world, your home, your office, as a private room in a gigantic global building. And the WANs? They're the hallways, the staircases, and the elevators that connect all of those rooms together. You absolutely need both to get around. And here's a perfect real-world example of that partnership. A remote worker needs to access files on their company's private LAN, so they use a VPN. What that VPN does is create a secure, encrypted tunnel through the public WAN, connecting them directly. It's basically like creating a virtual, private hallway that lets them act like they're sitting right there in the office. Every single time you go online, doesn't matter if you're sending a document to the printer right next to you or streaming a movie from a server thousands of miles away, your devices are seamlessly jumping back and forth from your local area network to the wide area network and back again. It's this constant, invisible dance. And all this leaves us with a pretty interesting thought for the future. With new tech like 5G and cloud networking popping up, the lines between our private, local networks and the big, global public network are starting to get really, really blurry. So as we move forward, where does one network actually end and the other begin?